Hi, this is Stefan Petersen from Aarhus University speaking, and this is a short instructional video on how to use ICEbear in SketchUp. So I'll just open SketchUp, and because I've already installed ICEbear according to another video here on the site, I have two icons. This little cute bear here that says click to open ICEbear, and another icon here says click to update building geometry for ICEbear. But before we can do a simulation, we need a building or a room geometry. So let me just make a simple shoebox model that we can do a thermal simulation on. So let's remove this guy here, and let's draw a simple shoebox. So now this is just a shoebox, and I want, of course, a window in this room. And the definition here in ICEbear is that this dotted green axis in SketchUp is south direction. So right now this surface here is vertical and facing south. So I want a south-facing window, so I draw a rectangle here on this surface. So if I wanted to the north, it would of course be on the other side. I can also rotate the room just using the standard commands in SketchUp. But the next thing we have to do is to define what are all these surfaces here in terms of building geometry. So we have to go and find our default tray, and inside the default tray we have to go to materials, and inside materials you will find a drop down here, a long one, and all the way to the bottom of this there's something called ICEbear materials, and you choose that one, and then you'll get these color palette that you have here. And if you hover over them, we can see that this says external geometry, this says external wall, floor, floor facing ground, roof, window inlet, window outlet, and windows. So now I want to define what are window openings in my shoebox. So I click here on the window, and then I go and click on whatever surface I want to be the window. So now this is defined as a window for ICEbear simulations, facing south with the tilt angle of 90 degrees. But that's not all. I also want to define the wall that the window sits in, and it's an external wall. So I have to go here and pick external wall and paint this as an external wall. So now we have an external wall that's facing outside and a window that is facing outside. We always need to define the floor of our model, and that floor can either be a floor or a floor facing ground. So if it's just a floor and it's facing another zone in the building, and therefore there's no heat loss of any significance across this slab, then we'll just paint it as a floor. If it was facing ground, we can represent that by choosing this floor facing ground. But right now I just want it to be facing another zone of assumed to be same temperature. And this is the first very simple model that one can do for ICEbear simulations. If you don't define other surfaces, you won't have a heat loss across them. They won't affect your thermal simulation at all, as long as you, if you don't paint them in any of these colors that we have here. So that's a simple room geometry for thermal simulation. So let's start ICEbear and see if we can get a thermal simulation up and running. So we press the little ICEbear here, and that should open our interface to ICEbear right here. So once you have done this, all the geometry that you have drawn here is transferred into ICEbear, and you can see that by just clicking this icon here, and here you will see all the areas that are just drawn. So apparently my floor here is 34.44 square meters. I have an external wall of this area, and of that I have a fenestration that is this area. And then I have a perimeter of my fenestration, which is 9.8 meter in this situation. And we would see everything else if we have drawn it right here. Right now you can see there's no U values for these constructions, but we have to define that now. So the input in terms of geometry is as expected. So to get started quickly, we just state how many people are there in this room. Let's say it's a 2-person office maybe. What location is it at? And here we can choose from whatever EPV file we choose to have as a part of the program. So here I choose a Danish design reference here. You can open a folder here to additional weather files, and this is also where you can copy and paste your own weather files for your own location. As long as it's in EPV format, you can always get it. And then we have to choose what is the glazing system, and there's a default database of glazing systems. In another video I'll come back to how to define your own glazings. But for this instance here, we could, for example, choose a double layer low energy coated glazing, standard type of glazing in many places. So we choose that one as the glazing. And then there's also a number of defaults for the remaining simulation settings. So if this is a landscape office with a variable air volume ventilation system, we can choose this template right here. So this is the fastest way to do that. In another video I will try to explain you how to customize these simulation settings that I just showed here. But this is actually all we need to make a thermal simulation for this room here. So now we're ready, and now we can press simulate. And here in the bottom you can see how far it is in the simulation. So now it's already done with a full annual simulation of 8,760 time steps. And we get some general overall results for this room here to the right in this panel here. So first of all, we have here the annual primary energy use, which is something that we use a lot in Denmark at least. But what happens here is that you get the energy consumption where the electricity has been multiplied by a primary energy factor, so we can add it to the heating. So now they are kind of equal, and we can add it up to a number. There's no daylight simulation in the SketchUp part of the tool. If you use, for example, Rhino Grasshopper, you can add Honeybee or Diva to do the daylight calculations, and a standalone daylight calculation for ICEbear is also under development. So right now there's no daylight calculation in this one, it's only thermal. And here we get an evaluation of the thermal indoor climate, where we can see that we don't want anything to be in the red zone, so here we have substantial overheating, it kind of indicates. And in terms of the air quality, it's evaluated according to the different classes in the European standards. So this is one way to show results. Another way is down here in more simulation results. If you would like to analyze this in another way, you can have the hourly simulation results, as you might know from any other thermal simulation tool. Here's the operative temperature, and we can see it's pretty overheated, the building that we're working on here. This is yearly. You can go and have a look at it on a daily basis. You can go and look at it on a weekly basis. You can add what is the occupancy load. You can add what is the outdoor temperature, and so on, monthly value, whatever you would like to show. So this is a standard way. Shading, is it on or off, and so on. So another way is to just look at the energy demands. So this is without the primary energy factors. So this is the energy needed for heating and for electricity, for heating in the zone, cooling in the zone. If you have a heating coil, if you have a cooling coil in your ventilation unit, the fan power used for ventilation, lighting, and hot water consumption for general purposes. So this is just an energy overview. You can get some daylight evaluation if you had the daylight simulation as well. You can get the indoor climate evaluated according to 15251, and you can get an hours above analysis. And this is a funny one because you can see it's completely off the chart. It's not a graphical error. This is something that is on purpose because it's simply just off the chart, the overheating here. But here you can count the hours above certain thresholds for your simulation. And then there's some additional stuff here for the Danish context, but I don't want to go into that detail now. So this is the way to get your first thermal simulation in ICEbear. Now we can try to play a little bit around with this. Now it's overheated. We use the 2-layer glazing. Maybe we could have a double glazing here with a dark sun coating, so we have a coating that reduces the solar load. And here we can just change it to this type of glazing. Press simulate and let's see what happens to the results. Oh, it substantially reduced my overheating, as you can see. Let's go and have a look at the results here. For example, for the indoor, the hourly values, as we can see it here, or we could have a look at the hours above analysis. Okay, this looks a little more reasonable now in terms of overheating. So this is the way that you can start to play around with the performance of your little building or room model that we have here. So if you want to change geometry, for example, you want to maybe move or make this, sorry, not that, here we take, for example, and change the window height to something else. Then we have a new geometry. So right now we saw that the geometry of the window, when we checked it here, it was 5.59. Okay, sorry, 5.53. So in order for us to update this geometry, you have to remember to press Update ICEbear. Unfortunately, we don't have an automatic command that does this once you have changed the geometry here. Whenever you change geometry, go and press here. And then we can go into ICEbear again, and hopefully you will see, yes, now the fenestration has changed to a smaller area of 2.98. And that's also if you choose to change whatever geometry, you have to remember, please, to press the update, and then you can do the simulation again, and we can just try to see what happens when we made a smaller glazing here. I completely eliminated the overheating issue. You could have other issues with this building design, but at least in terms of the overheating, it seems quite reasonable now for many purposes. So that's basically how to get started to do a new ICEbear simulation from scratch in ICEbear. I hope this was helpful. Thanks for watching.